We're going to be talking about mobile and embedded device security. This is Module 6 and Chapter 6 in our textbook. This is for our CompTIA Security Plus and the Information Assurance class. So, getting started, we should be able, by the end of this module, to list and compare the different types of mobile devices and their risks. We should be able to explain the ways to secure a mobile device, describe the vulnerabilities and security considerations of embedded and specialized devices, and explain how application security can provide protections. Starting off, the types of mobile devices include the following. So you have tablets, smartphones, wearable devices. The most common devices like these are the smartwatch. So here's an example of a tablet device. Here's an example of a smartwatch. The types of mobile devices include the following. You have portable computers. There's the devices that closely mirror the functionality of a desktop computer, like a laptop. They're smaller, self-contained devices that can easily be transported from one location to another while running on battery power. A web-based computer contains a limited version of an operating system and a browser with an integrated media player. The following here are different connectivity methods used to connect the modular or mobile devices to networks. The first is cellular. That gives a coverage area for a cellular telephony network. They're divided into cells. If you've taken your network class and they talked about that, that's like the honeycomb structure. So you have transmitters that are connected through a mobile telecommunications switching office, or MTSO, that controls all the transmitters in that cellular network. You have Wi-Fi, also known as wireless fidelity. It's a wireless local area network, or WLAN, that is designed to replace or supplement a wired local area network. More and more you'll see wireless networking devices using the hotspot or the wireless receiver. So here's an example of cell transmitters. You see the cell towers, the 3 cell towers that they're connecting to the MTSO. The following are different connectivity methods used to connect the mobile devices to networks. You have Bluetooth. That's a short-range radio frequency transmitter providing rapid device pairings like your earbuds to your phone, or if you have one of those Bluetooth speakers, or if you pair it with your car, the audio, so you can play your mobile data, your cellular data, the music, through the audio of the car. You also have USB connections, different types and sizes of universal serial bus connectors on mobile devices. That's now becoming a thing where you can hook up a USB to a smartphone and say transfer large files or just data transfer between devices. So you have bring your own device model. That's what we use here at YSU. So students, they bring their own personal mobile device. You have the corporate owned, personally enabled, COPE. They have your choose your own device. That's where you would choose from an already set list of provided devices. You would have your virtual desktop infrastructure or corporate owned. So in the old days when we still had the computers in the classrooms, that was our corporate owned example. So the following are the benefits of the BYOD, COPE, and CYOD models for the enterprise. And you can see you have management flexibility, less oversight, cost savings, simplified IT structure, reduced internal service, and increased employee performance. And you would ask yourself, well, gee, what are all those things for? Well, when you think about each one of those is an important bonus from bring your own device or any of the other scenarios that are set up in there. The following are the user benefits of the BYOD, COPE, and CYOD models. You have a choice of device, a choice of carrier, and convenience. Now, there are some risks with mobile devices. The increased reliance of businesses on mobile devices means that the employees must have access to sensitive data. So this has heightened the interest of threat actors toward mobile devices, because their goal or their idea is, if we can get into that mobile device, we can get access potentially to that company's data. So there's several security risks associated with using mobile devices, including the following: general mobile device vulnerabilities, connection vulnerabilities, and access untrusted content. The mobile device vulnerabilities include the following: physical security. Mobile devices are frequently lost or stolen. Limited updates. Not everybody updates everything like the system was when we had the computers there. Everybody has to make sure Windows Update or whatever is up to date. Location tracking. Mobile devices use geolocations that are an increased risk of targeted physical attacks. And unauthorized recording. By infecting a device with malware, a threat actor can spy on unsuspecting victim and record conversations or videos. So here are some additional connection vulnerabilities: tethering, USB on the go, malicious USB cable, and even hotspots. Anywhere somebody can connect or access the internet, that's potentially, with a wireless signal, a weak spot unless it's encrypted or taken care of. One of the things you would learn also when you're networking, there's the ability for someone to come along with a transmitter that's more powerful than the authorized one, and mobile devices will tend to connect with the more powerful one, and that attacker would be able to get access to all the information that they're sending. Users can circumvent the built-in installation limitation of their smartphone. That's called jailbreaking on the Apple iOS or rooting on the Android to download from an official third-party app store. That's also called sideloading. The untrusted content can then invade mobile devices through SMS, MMS, and RCS text messaging. The mobile devices then can access untrusted content using QR codes. An attacker can create an advertisement using or listing a reputable website, but also include a QR code that contains a malicious URL. And once that's clicked on, then you've got additional problems. So you also have the ability to protect your mobile devices, and these following configurations should be considered because this now provides you extra protection. The first is use strong authentication. Verify the authentic user of a device involves requiring a strong passcode and restricting unauthorized users with a screen lock. Oftentimes you'll see a phone or a mobile device locked requiring some like a PIN or other kind of passcode to unlock it, or fingerprint or facial recognition, or like his last one, a pattern connecting dots to unlock the device. Secondly, these following configurations should also be considered: segmentation. So that means separating business data from personal data on the mobile devices. Users can apply containerization, or separating storage into business and personal containers. It helps companies avoid data ownership, privacy issues, and legal concerns regarding a user's personal data stored on that device. You can enable loss or theft services. Several security features can be used to locate a lost or stolen device. If a lost or stolen device cannot be located, it may be necessary to perform what's called a remote wipe, because you don't want them to get your contacts and other information. And so you can either have it set up with the carrier, and they can send out a signal to basically reset the phone back to factory default so nobody can get access to your information. You also have the ability to have the device generate an alarm, or have the device last known location. If you have the device GPS in there, it can have a locate function. You can have remote lockout and a custom message that's displayed on the login screen. Or a thief who incorrectly types in the password 3 times will have their picture taken and then emailed to the owner. So you have mobile device management, mobile application management, mobile content management, and unified endpoint management. Each of them look to manage data or the device differently. The first one is to allow it to be managed remotely by an organization. The second one is to control how access to apps are to be handled. The third one, you're modifying the digital content by multiple employees. And the last one, you're managing and securing mobile devices, applications, and content. Okay, so let's take a look at our first check activity here. We have Ozan, who's received a phone call from his superior that a new employee has attempted to download and install an unapproved app that allows her to circumvent the built-in limitations on her Android smartphone. What is this called? What is the process of downloading and installing an unapproved app that allows her to circumvent the built-in limitations on her Android smartphone? So you got 4 choices here. First one's rooting, side loading, jailbreaking, and ducking. Well, if we do this from a process of elimination, we know it's not ducking. Jailbreaking, that's on iOS. Side loading is installing software after it's been broken. And so it has to be rooting since it's an Android smartphone. And as we look at it, that's the answer we have here. Rooting. Users who circumvent the installed built-in limitations on their smartphone are jailbreaking on the Apple iOS devices and rooting on Android devices. So let's talk about embedded systems and specialized devices. Computing capabilities can be integrated into appliances and other devices. An embedded system is a computer hardware and software contained within a larger system designed for a specific function. Protection of these devices needs to be considered. So, the types of devices, you have hardware and software. The most common hardware component is the Raspberry Pi, which is a low-cost, credit card-sized computer motherboard. A device similar to the Raspberry Pi is the Arduino. So you have Field Programmable Gate Array, or FPGA. It's a hardware chip that can be programmed by the user to carry out one or more logical operations. A system on a chip, SoC, combines all the required electronic circuits of the various computer components onto a single chip. Those SoCs also can use a real-time operating system. Okay, your industrial systems, you have your industrial control system. So you have those ICSs are managed by supervisory control and data acquisition, SCADA systems. So SCADA systems help to maintain efficiency and so your SCADA systems help maintain efficiency and provide information on issues to help reduce downtime. You have specialized systems. Digital smart meters are used to measure the amount of utilities consumed. Smart meters have several advantages over analog meters. Other specialized systems include medical systems, aircraft, and vehicles. The embedded systems in cars use things like sonar, radar, laser emitters to control things like brake, steering, and the throttle. So here we have the types of devices: that meter readings, servicing, tamper protection, emergency communication. You can see what's offered under an analog meter and what's offered under a smart meter. So I'm going to take a minute and compare the two of these. Okay. So if you look at this smart cars, and these are the embedded systems in cars, and you can see all of these things: airbags, engine, your night vision, your windshield, heads-up display, driver alertness. You have electric power steering. On the right side, you have your battery, lane connection, electronic toll CD indicator. Digital turn signals. You have your active suspension, things like that. Then you have, wow, the whole world of Internet of Things. That's connecting any device to the internet for the purpose of sending and receiving data to be acted upon. All those devices, they include wearable technology like your watches, smartwatches, your if you have like the Google Home or Amazon Echo or any of those things. So home automation items, thermostats, coffee makers, tire sensors, slow cookers, keyless entry systems, washing machines, electric toothbrushes, headphones, and light bulbs, and more. It's estimated that in 2022, the average number of connected devices per household was 22. I think that's gone up since then. There are significant security concerns surrounding SCADA systems, specialized systems, and Internet of Things devices. These devices have low resilience to resist attacks. Improving the security of these systems begins with knowing the security constraints. There's also specific hardening techniques and technologies for ICS SCADA systems, some of which are being addressed by new legislation and regulations. One security constraint involves adding cryptography to embedded devices. Cryptographic algorithms require time and energy, which is in short supply for low power devices. This results in a resource security constraint. The following are some of the steps that can be taken to harden an SCADA and ICS system. Clearly define the security roles, responsibilities, and authorities for managers, system administrators, and users. Identify security requirements. Disconnect unnecessary connections to the SCADA network. Do not rely on proprietary protocols to protect the network. Test to identify and evaluate possible attack vectors or attack scenarios. Evaluate and strengthen the security of all connections to the SCADA network. Federal and state laws that have recently been passed to address the protection of the embedded devices and IoT. You have the Internet of Things Cybersecurity Improvement Act of 2020. It requires agencies to increase the cybersecurity for IoT owned and controlled by the federal government. The law, California and Oregon passed a state law addressing Internet of Things security that went into effect in 2020. Okay, the law requires that connected devices be supplied with You have your regulatory bodies that have begun mandating protections in IoT devices. In late 2022, the U.S. Food and Drug Administration gained new powers from legislators to set minimum security standards for medical device manufacturers. Okay, so which type of OS is typically found on an embedded system? Which type of OS is typically found? Which type of OS is particularly found in an embedded system? Any ideas? So the answer is RTOS. The SoCs often use a real-time operating system that is specifically designed for OS for an SoC in the embedded or specialized system. So think about that, how that works. There's some other applications for security. The executable files attack that tricks the vulnerable application into modifying or creating an executable file on that system tampering, and process spawning control. Some general concepts: developing an application requires completing following stages: development, testing, staging, and production. If you remember from your life cycle model, you have an application development life cycle model. It's a conceptual model that describes the different stages involving in creating the application. In the waterfall model, they use a sequential design process. The agile model takes the incremental approach, which allows for software issues to be incrementally be discovered and corrected and changed. Secure DevOps, or SecDevOps, is the process of integrating secure development best practices and methodologies into application software development and deployment processes using the Agile model. The SecDevOps applies automated courses of action to develop code as quickly and securely as possible that enables the following. So you have continuous monitoring, continuous validation, continuous integration, continuous delivery, and continuous deployment. And some secure coding techniques. Several coding techniques should be used to create secure applications and limit the data exposure or disclosing sensitive data to attackers. These techniques include determining how encryption will be implemented, ensuring that memory management was handled correctly so as not to introduce memory vulnerabilities. Also, you can have testing. Testing is one of the most important steps in secure DevOps. Testing should be performed during the implementation and verification phases of a software development process. Testing involves static code analysis and dynamic code analysis. In static code analysis, their tests are run before the source code is even compiled and may be accompanied by manual peer review. With dynamic code analysis, that's after the source code is compiled. That's called dynamic code analysis or runtime verification. Fuzzing is used by dynamic code analysis tools and provides a random input to a program in an attempt to trigger exceptions. Exceptions could include memory corruption, program crashes, or security breaches. So you can see here is an example. You have an automated static code analysis tool. This is before it's compiled, remember. Before it's compiled. So you can see the questions it's picking up here. You have a division by 0 at line 30, potentially. You have other issues. So that can bring up things that you didn't plan for to improve your code and make it more secure so that somebody doesn't type in a 0 and crash the program. One of the big things in a hacker might do is to cause the program to crash, and in some cases that would allow the vulnerability of the server to be open if it's running on there. For instance, if you crash the FTP port, it'll stay running, but it will be a fault and potentially allow the attacker to gain access to the server. Your fuzzer input generator, here's an example of that. And we have our next knowledge check activity, number 3. So what's another name for runtime verification? Runtime verification. Runtime verification. It's not fuzzering. It's not weighted code analysis. So it's going to be either A or B. Remember, static was the analysis before you compiled it. So dynamic, which then uses fuzzering, is going to be our answer here. Dynamic code analysis, that's where you have security testing that's performed after the source code is compiled on either dynamic code analysis or runtime verification when all components are integrated and running. Okay, so this is the end of our module or our chapter. You should rate your competence on the following module objectives on a scale of 1 to 5, where 5 indicates that you have full confidence in your competence of that objective, and 1 indicates that you have very little confidence in your competence. You should do this as a self-awareness, and don't just say, yeah, I got it right, or I'll get it right. Do an objective review of yourself, because then if you have to, you should go back and then review that model and the related exercises. Go review that module and see where it is you have to do what you need to do. Remember, it's not just here or even just passing the test. It's your goal, because your eventual goal is to go and take the CompTIA Security Plus exam, and you need to know this information. So wherever this is your chance to find out where you might need to review one or two items. So you want to list and compare the different types of mobile devices and their risks. Remember, we talked the different types of mobile devices: smartphones, you have your tablets, you have your laptops, you have your so on and so forth, all the different mobile devices. Explain the ways to secure a mobile device. Describe the vulnerabilities and security considerations of embedded and specialized devices. What are the security vulnerabilities? What are the security considerations? Explain how application security can provide protections. Okay. And again, this is the end of the module and the chapter. Okay. I will see you in the next chapter. Have a great day.